Determine if the system of linear equations is inconsistent or dependent. If dependent, find the complete solution. The system is inconsistent if it has no solution, and it is dependent if it has infinitely many solutions. First, we obtain an augmented matrix for the system of equation 1x, 1y, 1z, 2. 0x, 1y, negative 3z, 1. 2x, 1y, 5z, 0. We will turn this matrix into either reduced or row echelon form. First, to turn the entry 2 in the third row to 0, we will take negative 2 times row 1 and add to row 3. If we take negative 2 times row 1, we will get negative 2, negative 2, negative 2, and negative 2 times 2 is negative 4. Row 3 is 2, 1, 5, 0. Adding column wise, we'll get 0, negative 1, 3, negative 4. And these are going to be the entries in row 3 in the equivalent matrix. We keep the first two rows, 1, 1, 1, 2, 0, 1, negative 3, 1. And the third row is now 0, negative 1, 3, negative 4. Next, we will turn the non-zero entry negative 1 in the third row to 0 because the goal is to obtain the diagonal ones. To turn negative 1 in the third row to 0, we can take row 2 and add it to row 3. If we take row 2 and add to row 3, we obtain entries that will go to row 3. We keep the first two rows, 1, 1, 1, 2, 0, 1, negative 3, 1. But the third row is now 0, 1 plus negative 1 is 0, negative 3 plus 3 is 0, and 1 plus negative 4 is negative 3. The last row states that 0z equals negative 3, or simply put, 0 equals negative 3. Remember that the dot dot or the vertical line is where the equal signs are. 0 can never be negative 3. This is a false statement. What this implies is that the system had no solution. If the system had no solution, it is said to be inconsistent. And we stop right there.